let's say we wanted to compute an indefinite integral like this one here. Okay, first of all, what does indefinite mean? Indefinite means that we're not going to put bounds on our integral here. So what we're looking for in general is an antiderivative. Okay? Usually we're looking for the area from the beginning, like from some a here to some b here, but that's not what we're looking for here. We're just looking for the antiderivative of this stuff. Now, if you just try and think up an antiderivative of this stuff, you're going to run into a few problems. First of all, this is like a quotient rule thing here. So it's pretty tough actually to figure out what you would start with. If you had just like 5x, that's easy. You can just eyeball that and see what an antiderivative would be. Like 5x squared over 2 would do the trick for that one. But for this one, that's a little more difficult. I can't think of something off the top of my head to do that. And I don't know how to split it either, because you can't split this. This isn't like x to the 1/7 minus 4 to the 1/7. And you can't then split that over that. That's just not how that works. So we're going to have to do something about that. What we do is your first integration technique, which is substitution. U-substitution. So we should pick something for a substitution. For problems like this, since the problem is the x minus 4 part, let's try u equals x minus 4. And it's just our first try. Sometimes the first try for substitution doesn't yield any results, and that's fine. Then we'll try something else. I think this one's going to work. So if u equals x minus 4, that means du equals dx. How the hell did I get that? Well, these things increase at the same rate. Okay, if I look at the rate of change of u and the rate of change of x minus 4, they increase at exactly the same rate. Okay, really what you're doing is you're taking the derivative of this side, or you're taking the derivative of the whole thing, and the derivative of the negative 4 is just 0, and you get du equals dx. How you want to think about that, or how I like to think about that, is that as you increase u, x minus 4 increases by the exact same amount, which makes sense. If it was a 2x out in front of here, then it would increase twice as fast on that right side of the equation. Okay, if we rearrange for x, we get that x is equal to u plus 4. So I just brought the 4 on the other side, no problems there. Now we trade in all our x values for u values like a boss. So when we do use substitution, you don't just trade in some of your x's for u's. You trade in all of your x's for u's, including your dx. You have to trade in everything that has an x for a u. Usually, if you have some limits of integration, some bounds of integration, you could even change those to be in terms of u. You don't have to, but you can even do that. Let's see what happens when we trade in all our x's for u. So 5x becomes 5u plus 4 because x is u plus 4. The 7th root of x minus 4 becomes the 7th root of u because that's what we picked u to be. We picked u to be x minus 4. So that's awesome. Now we have the sum on the top and some shit on the bottom, which is fine because we might be able to split that. Remember, if you have something plus something over something else in your fraction, you can split that into two fractions. Okay, oh look, that's what I do here. So you multiply the 5 out if you want. You can even factor out the 5 from the integral. That's whichever way you want to do it. So you have this, and then you have this. And then you can split the integral up as well. So that splits up to the integral of this times du, and then integral of this times du. Just like sums would work. If you can do it with sums in general, you can do it with integrals. Because integrals are just sums of an infinite number of things. Well, an infinite continuous number of things. Okay, so you have this. You can factor out the 5 here. You can factor out the 20 here from this integral. And just be careful with your exponents. That's the tough part here. So like u, this is u to the 7 over 7. This is u to the 1 over 7. So in total, you have u to the 6 over 7. Notice I have not computed any derivatives yet. I'm just simplifying this a little bit so that it's easier when we finally do take the integral. Okay, let's take the integral of this. So forget the 5. The 5 just stays out front. It's just a constant. So I need to pick something, u to some power, such that when I take its derivative, I generate u to the 6 over 7. In general, you just add one full power of u. So 7/7 of u get added onto this. So I have u to the 6 plus 7 over 7. That's where this 13 comes from. Now the problem is, if I just have u to the 13 over 7, forget about the 7 over 13 for now. I'm just about to explain where that comes from. If I just say my antiderivative of u to the 6 over 7 is u to the 13 over 7, when I take that derivative, remember the 13 over 7 comes down before I subtract 7 from the top there, from the 13. So, but then if I have a multiple of 13 over 7, that's not going to give me 5 u to the 6 over 7. That's going to give me 13 over 7. That's why I multiply by 7 over 13, so that everything cancels out. All right, the 13 is going to cancel with 13 from the bottom, 7 from the top is cancelled from 7 from the bottom, and you're just left with u to the 6 over 7, and then the 5 is still there. Okay, so that's where all this mumbo-jumbo comes from. Now, plus this one here. So this is on the numerator, really. This is u to the negative 1/7. And so if I add a full power of u to that, I have to add 7/7. So I get u to the 6 over 7. So you can test that. You can test what's the derivative of u to the 6 over 7. Well, the 6 over 7 would come down, and then I would minus 7 over 7 from the 6 over 7, which would give me u to the negative 1/7, which is exactly what we have above. Except we've got, remember, we had the 6 over 7 constant in front. That's why I should multiply by 7 over 6 to cancel all these guys out. And then I leave the 20 there so that I get my 20 over u to the 1/7. Okay, you can test these. So you can take the derivative of this, see if you generate this. Take the derivative of this, see if you generate this. You need to be able to do that. That needs to happen. Now, oh, I didn't say all my substitutions. dx becomes du. That's very important. You're now integrating with respect to du. All right, don't forget that. That's really important for some of the other substitution problems. Okay. So now that this job is done, you're pretty much done at this stage. The only thing you have to do, which depending on what your task is, you don't even have to do it sometimes, but I'm pretty sure in this question you should do it. Replace your u with what your substitution was. So originally we said u was x minus 4. So take all your u's and replace them with x minus 4. So, and don't forget your constant. Your constant integration is super important for indefinite integrals. They'll mark you as wrong if you forget that constant. Okay, that's really important to remember. Yeah, so after that, you just plug in your u values as x minus 4, and then you have this thing here. Would you simplify this? I wouldn't. You know, especially if I'm on a test. I don't got time for that shit. If I was doing an assignment, I might take the extra time to simplify that. But on the test, I think you're going to get full marks for this. That's just great. So hopefully that makes sense. Shoot me an email or Facebook if you have any questions about that, or if you want me to do any other questions. And rock on, keep working hard, and until next time, see ya.